Welcome back, my math-loving friends. So in section 1.5, we are looking at solution sets of linear systems. And you may be thinking to yourself, well, haven't we been looking at solution sets to linear systems? And yes, we have. But here, we're going to be providing both an explicit and geometric description of the solution set of a linear system in much more detail. So get excited. Here we go. We're going to start by exploring homogeneous linear systems. So a system of linear equations is said to be homogeneous if it can be written in the following form. So a linear system is homogeneous if it can be written as matrix A times vector x equals the zero vector. And this is such that matrix A is some m by n matrix. This zero vector is, of course, the zero vector, but this is the zero vector in Rm. And vector x is still that vector in Rn. So a system of linear equations is homogeneous, or said to be homogeneous, if we can write it in the form matrix A times vector x equals the zero vector. Now, homogeneous equations always have at least one solution. And I bet you can guess what that solution is. It's the zero vector. So homogeneous equations always have at least one solution, the zero vector. Now, this is the zero vector in Rn. And we call this solution the trivial solution. So a homogeneous linear system or homogeneous equation always has a trivial solution, the zero vector. So for a homogeneous equation, matrix A times vector x equals the zero vector, the question we're going to be asking ourselves, or that we're going to be concerned with, is determining whether or not this homogeneous equation has another solution. So we are going to be asking ourselves, does a non-trivial solution exist? So does a non-trivial solution exist for our homogeneous equation? So looking at the definition of a trivial solution, we can say that a non-trivial solution is a non-zero vector that satisfies the homogeneous equation. So we are looking for a non-zero vector in Rn that satisfies the homogeneous equation. Matrix A times vector x equals the zero vector. So how are we going to do this? Well, we can pretty quickly determine what we need to look for by thinking back to the very beginning of the course. So let's recall that if a linear system is consistent, so if a linear system is consistent, then the solution set contains one of two possibilities. So then the solution set contains either a unique solution or infinitely many solutions. So if a linear system is consistent, it has at least one solution, which tells us that then the solution set contains either a unique solution, meaning that there's no free variables, or the solution set will have infinitely many solutions, meaning that at least one free variable exists. So at least one free variable exists. So if a homogeneous equation has one unique solution, the trivial solution, then a homogeneous equation is going to have a non-trivial solution if at least one free variable exists. So that's what we're going to use to check if our homogeneous equation has a non-trivial solution. So we can make the statement that a homogeneous equation matrix A times vector x equals a 0 vector has a non-trivial solution if and only if, or when, at least one free variable exists. So that's what we're going to use to check here. We can determine if our homogeneous equation has a non-trivial solution if at least one free variable exists.